everybody. Welcome to today's lesson. Thank you so much for joining me today. Let's go ahead and take a look at today's lesson objective. So today we will apply the distributive and commutative properties to relate multiplication facts. The TEKS we will be covering today is 3.4e, 3.4k, 3.5d, 3.5e, 3.4d, and 3.4h. Okay, let's take a quick review of what is the commutative property of multiplication. So the commutative property of multiplication states that numbers can be multiplied in any order and the product or the answer will be the same. Okay, now let's go ahead and take a look at the distributive property of multiplication. So the distributive property of multiplication states that when you multiply two numbers, you can decompose one number into two parts, multiply each part by the other number, and then add them together. So if we have 6 groups of 3 and 5, or if we combine them together, this would be 8. Right? So if we take 6 groups of 3 plus 5, so 6 times 3 plus 5, or we could do 6 times 3 plus 6 times 5, and our product would be the same. The answer would be the same when we combine everything together. All right, let's go ahead and take a look at this problem for today. So this one circle, this one right here, represents 1 unit of 7. So let's go ahead and count and see how many 7s we have. So we have 1 7, 2 7s, 3 7s, 4 7s, and 5 7s. Okay, so this multiplication sentence that would represent these 5 7s would be 5 times 7. Okay, so we're going to go ahead and this could be 5 times 7, or according to the commutative property, it can also be 7 times 5, right? So if we take 5 times 7, or 7 times 5, that is going to equal 35. All right? So now, we're kind of familiar with 5s, right? Because we can do 5, 10, 15, 20, 25, 30, 35. In the same way, since we know our 5s, we can go ahead and flip them, and now we know that 7 times 5 is 35. Okay, now what about if I go ahead and add one more 7? Now how many 7s do I have? I have 6 7s. So to represent this with a multiplication sentence, we have 6 times 7, or 6 groups of 7, which is the same as 7 times 6, right? But we have one more 7. So we know that 7 times 5 is 35. So all we have to do is add one more 7 to 35. So if I have 35 plus 7, that is going to give me 5 plus 7, which is 12. I'm going to put down my 2, take 10 of those ones, turn them into a 10, and now I have 1 plus 3, which gives me 4 10s. So 6 times 7 is equal to 42. Okay, let's go ahead and try this with another sentence. But this time, we're going to go ahead and try this with 9s. So let's count how many 9s we have. We have 1 9, 2 9s, 3 9s, 4 9s, and 5 9s. So this is going to represent 5 groups of 9, or 9 times 5, right? So 9 times 5, or 5 times 9, is equal to 45. Now, what about if I have one more 9? Now I have 6 9, so I have one more 9, then 9 times 5. So I can go ahead and add one more 9 to 45. because now I have 6 nines instead of 5 nines. So 5 plus 9 is 14. I'm going to leave 4 of those ones, take 10 of those ones, turn them into a 10, and then I have 1 plus 4, which is 5. So we now know that 6 nines, or 6 times 9, which is equal to 9 times 6, is equal to 54. Okay, let's review today's lesson objective. So today we applied the distributive and commutative properties to relate multiplication facts. Okay, everybody, thank you so much for joining me today. I hope this was a helpful lesson. So we can go ahead and use this lesson to help making multiplying of other number facts that we may not know, like some of the more complicated ones, like 7, 8s, and 9s, multiplying those facts. And we can use a commutative and distributive property to make it a little bit easier for us to understand and memorize these facts. All right, everyone. Thank you so much for joining me today. It really was a pleasure working with y'all, and I'll see you next lesson. Bye, everybody.